Stefan is product marketing manager for service providers at SevOne. Why don't we, since we've heard so much about AOptix, why don't you tell us a little bit about SevOne?
Sure, thanks so much. So SevOne, it's an infrastructure management software vendor. We manage multi-vendor, multi-technology, multi-domain, backhaul, radio access, packet core, application, cloud, SDN type infrastructures.
Great. So, I think Christina's amplified the importance of backhaul as we deploy LTE networks. And in fact, when you think back to the very first LTE networks that were deployed, they were deployed at the RAN, but nobody bothered to change out the backhaul. And if you remember the user experience back then, particularly on AT&T's network, it was miserable. The signal got to the base station, but didn't go anywhere beyond the base station. And as more and more users piled on, we found the backhaul being the chokehold in the network. And we had to suffer through that for a while because it took time for AT&T to upgrade the backhaul that was already in place supporting their 3G network. And if you know anything about backhaul, you can't just replace it. You have to go through a very lengthy process of procuring new backhaul and deploying it. So it took 9 months, maybe more, by the time those upgrades took place. And it was pretty painful. Verizon came a little faster and deployed backhaul more quickly, and the user experience was a bit different there, and we didn't have to go through that process as much. But in fact, I believe backhaul has been running behind the capacity growth, the data traffic growth all this time. And Cisco keeps producing numbers, or Ericsson for that matter, about how rapidly data traffic is growing, and we're not keeping up with that growth on the backhaul. We're assuming that somehow the traffic will be captured at the RAN, and the backhaul will just take care of itself. But it's not at all true. So we need to think about the end-to-end performance of networks. We need to treat backhaul not only as a critical piece of the overall architecture, but more importantly, as the most important link in terms of throughput, as far as actual performance. Because I can be hanging on that macro cell all day long, but if I don't have any backhaul, I'm in trouble. So when you think about that, what is driving backhaul in the next stage of the evolution of these LTE networks? We're moving from a macro-centric environment in which all LTE traffic is run over macros to a HETnet environment in which LTE now is being distributed not just over large macro cells, but in fact the macro is almost becoming the hub for a HETnet, and aggregation of small cell traffic, maybe DAS traffic, maybe Wi-Fi traffic is occurring, and we're needing an architecture that's more scalable, that in fact creates aggregation points so that traffic can flow more efficiently through the network. Maybe at the small cell level, I can have very relatively thin pipes, but between the aggregation point and the rest of the network, I need much bigger pipes. So, I know SevOne looks at backhaul end to end, and I know in your experience in providing the monitoring and performance testing, you sense this right away. You obviously see the problems in backhaul from the beginning, right? Tell us a little about it.
Yeah, look, that's our bread and butter. That's where we come from. Just, show of hands. Who here owns their backhaul end to end?
Nobody.
That's.
And who are you? Okay, because you're the fixed operator. Okay, but it's not entirely true, because there's an out of region for Verizon where you don't own network, right? And there are instances where you use third-party providers or you use dedicated links, right? So you own it in some places, not in others. Okay, how about you? Okay, and what company are you with? Okay, great. So
it comes with a follow-up question. How often do you look at your backhaul capacity before making planning decisions? So it's a learning experience, right? It's one of those things. If for you guys who were here during the self-optimizing networks panel, right? And we were talking about SON. It's radio. It's like, yeah, you can optimize your radio all you want, but you're still going to hit backhaul, right? And there's going to be problems there, and you're going to have to change your optimization to meet the backhaul requirements. So as you're thinking, deployment of LTE, you're moving into smaller cells, right? Your fat pipes of 5 years ago are now your thin pipes to your small cell deployments. Your fat pipes take months to deploy and develop, right? Between, testing technology in the lab, cool technology on, your laser radio, right? You're not just going to go in and say, yep, I'm sending 5,000 people into every site that I have to replace my infrastructure today, right? You're going to have a rollout plan. It's going to take a while. So what we're seeing is people are taking more into consideration that I just don't want to see my network performance as a packet core number of attached subscribers or links going out to the internet or applications per second. I don't just want to see my radio in terms of number of subscribers. I want to see the whole thing and then make decisions with the money that say, okay, for this site, yeah, we're my projections say that I should have probably a couple of 10 gig pipes coming here and make those decisions early. So, that enhanced visibility early on makes a difference because I know if you're painful experiences. We've been monitoring them.
So in fact, SevOne plays a role in network planning, not just monitoring right?
Correct.
So in fact, being able to predict those bottlenecks, being able to see what's coming so that you can tell carriers, hey, this is an area where you're running behind, and you need to go back and because the lead time is too long for them to be able to do it instantaneously.
Absolutely. And what you see for example, for smaller sites, where you're going for on-demand connectivity and on-demand bandwidth, right? You still have manual processes of picking up the phone, ringing someone, or clicking on a web portal and saying, hey, this site needs double the bandwidth for the next 2-3 hours. We're getting a lot of customers really interested in how can they automate that process, right? That planning process to say, okay, we can actually deploy technologies that can give you either bigger pipes or pipes on demand, right? Can we skip doing the bigger pipes for a while and instead manage our service on demand?
So I'm going to ask the next question to Christina as part of her Q&A, as an extension of her session. Obviously operators are testing high-capacity backhaul and are using different technologies in that environment, yours being one of them. And certainly you can address this just from an AOptix point of view, but you have some visibility into what other stuff is being tested at the same time and how your technology compares to other emerging backhaul technologies. So right now we treat it as fiber microwave, kind of a duopoly as far as that's concerned. But now we have another form that is wireless fiber, effectively. So how do you see this whole emerging testing environment? Where are we going with that?
Yeah, so there's a lot of technologies that are going to, the way I like to describe it is to actually solve the problem of both 4G and 5G for that matter, you need a toolbox full of different types of technologies. And obviously, as you said, fiber and microwave have really carried the lion's share of backhaul up to this point. But as we go forward, we need more tools and we need them quickly. So you've got things like laser radio, which you guys just heard about, which gives you some new options in terms of your macro cell backhaul, larger pipes, 2 gigs, then 10 and 40 in the future. And then, of course, we've got the opportunities for more small cells and things like short-range millimeter wave in those deployments, as well as some of the Wi-Fi that is available now to help bolster those different areas of the network. And if you take all of these different technologies together, as you're mapping out your network, you can look through, which, if we do that whole capacity, distance, availability Venn diagram that we were talking about before, which one fits each particular need. And so I see all these technologies as complementary. There's not going to be just one that will be the key shareholder going forward. It's going to take all of them to successfully build the network out.
So if we look at the evolution of LTE networks from being macrocentric to being headnet oriented, and we start seeing where backhaul starts to become segmented and plays a role in bringing traffic from the edge to an aggregation point, and then from there transport back. Where does laser radio fit into that story? Where are you? Are you at the edge? Where are you?
No, so we're definitely, being a larger capacity product, at this point in time for 4G, we're definitely a macro cell backhaul solution. And we work in concert with the small cell solutions to create the full path back to the mobile switching center. But there's definitely, as we move forward and small cells are driving more and more capacity, you could have at the small cell aggregation point one of our smaller units, which would be the 2 gig product going forward.
So, you know, the Verizon member of this panel, who's sitting in the front row, has got a strategy where, in fact, his small cells are grouped together and the traffic is backhauled, not individually necessarily, but through to an aggregation point. I would think that would be an obvious place to put high-capacity radio. But the question is, how much of that is needs line of sight in order to achieve that, number one? And what happens when you aim that beam and there's a building in the way, or there's some other obstacle that you can't get around? Don't you need a clear shot?
You absolutely do. And that's why it has to be a toolbox, and you need complementary technologies to work together, because it's specifically going to be a line of sight, point-to-point solution, like we talked about before. But it works in concert with some of your non-line of sight technologies where you may be needing to compromise on other things. Maybe you don't get as much capacity, maybe you don't get as much distance. So by using those two things complementary together, then you can build out a larger solution that you'll be able to use this one in the places where you can get line of sight. And keep in mind that usually we're talking about things up on towers, right? So in most locations, you're going to be able to get line of sight in the macro cell backhaul distances that you need to get. So in a lot of situations, it fits that solution.
So I was talking about use cases, and a lot of the small cell deployments are in urban areas. And clearly, you know, there are tall buildings and things in the way. And even though there may be macros nearby, you don't necessarily have a line of sight shot to those tall buildings. How do you gain that kind of line of sight perspective? Do you get to the top of a tall building, even though the small cells may be deployed at street level? Or you have an in-building solution, you have small cells and DAS throughout a building, but you come out the top and you shoot across to a site? Because in fact, if you're going fiber, you're going to go the other way, right? You're going to come down to the street.
That's true.
So you got to rethink your backhaul strategy, right?
Right, and you know, fiber has its own challenges. Whenever you're trenching new fiber, you're always going to have to go around any obstacles that are in the way. But this is a situation where if you're going into the small cell, you're just, as we talked about before, just doing it at the aggregation site. So certainly off a building, you could point down into an aggregation site. And then when you're doing the macro cell backhaul, you're usually going tower to tower.
So, you know, you guys have visibility into a lot of carriers, but equally, you know who the backhaul providers are. And in many cases, they are carriers in and of themselves. They're not wireless carriers, but they're backhaul carriers. They're specialists in backhaul. How well are they meeting the requirements of LTE deployments as they start scaling up? And are they keeping pace with the demand for traffic?
I think in a nutshell, most of the wireline carriers that are doing backhaul are not keeping up with LTE traffic demands. Why? It's you know, it's another service on top of the network. It might not be the main revenue driver for their operations, and in most cases, you know, they're showing a product that's, you know, geared towards enterprise access and repurposing it for, you know, access to either the small cell or even the macro cell in some cases, right? And it's a different way of thinking about access when you're competing against an enterprise fast internet service that it's meant to deliver some semblance of 100 meg capacity over a link, right? But no one cares if it actually drops down the threshold because this IT applications adapt compared to, well, we are going to have 100 meg sustained capacity here, right? So we need a different class of service, a class of service that most of them are not willing to offer.
But in fact, what we're driving toward at the macro is to be directly fed by fiber.
Correct.
We're talking about gigabit capacity at fiber speed at these macros.
Yeah.
But in fact, nobody deployed macros to be on the fiber network. In fact, in many cases, they're off to the right or the left. Off, from there, you got to bring a lateral over to get access to that fiber.
Yeah.
It would seem to me then that we need some other alternative in order to make fiber-like performance available to these macros.
Absolutely. And, as you were saying, it's a combination of tools, right? You're going to need point-to-point radio. You're going to need point-to-multiple. You're going to need, short haul back to fiber rings. You're going to need better performing Metro Ethernet. You're going to need a lot of things to actually meet those demands.
How is that useful if I bring fiber all the way near the macro, but in order to get to the macro, I have to drop down in terms of bandwidth and capacity by going onto microwave? Doesn't help, right?
No, doesn't help at all.
Right. So I end up with the weakest link being the speed of the pipe. So that's where I think we see AOptix technology fitting in here, is not necessarily a replacement for the fiber, but an extension of the fiber to actually deliver that fiber performance to the point where you need it.
Right, because what you're really talking about is last mile access of sorts, but this time to a cell site instead of just to a building or an enterprise. And last mile access is certainly something that we have a lot of opportunities in from the AOptix perspective. And so if you think about just trying to get that last 1 to 10 kilometers between the last fiber drop and where you're trying to go to your cell site, that's one way you could keep those gigabit capacities going.
Yeah, I tend to think of it as the first mile, not the last mile, but I hear your point.
Or some people call it the worst mile.
The worst mile is another point.
Berge, 1 minute?
Do I what?
1 minute?
Oh, I have 1 minute?
Yes.
Is that what you said?
Yes.
Okay. I thought you wanted to talk to me in 1 minute. So SevOne has some unique infrastructure monitoring capabilities that deal with this end-to-end performance and address backhaul as part of that overall architecture. What are some of the differentiators there?
So for us, the differentiator is that a lot of the traditional infrastructure management platforms focus on the IT side of the equipment, right? And they treat the telco side of equipment as if it has leprosy. I just don't want to get data from, my radio management systems. I don't want to touch the EMSs. I want to do things like that. We actually go end to end. We go direct to the device, or we go to the EMS, or we go through other mechanisms to get data from every layer of the network to actually provide that end-to-end visibility, which in the case of people like Verizon, it gives a tremendous advantage because your last mile is no longer a blind mile, which is something that happens a lot to service providers, because you're monitoring end-to-end these tools, using these tools all the way down to the point where you drop off. And you have no visibility of a need, if that's what you put as your demarcation point, or you have no visibility into a microwave radio, or if you're handing off to a second service provider, you have no visibility on the performance of their link. You can't run some SLA test to say, okay, my delay, my jitter, my round trip time here are within parameters. And getting data from every layer of the network, mediating it into a standard format, and then reporting on it, right? It's invaluable to find out which last miles are performing, which ones are not.
Okay, now it's one thing to have end-to-end visibility and see it retrospectively. So you give me reports, I find out my performance was bad. What do I do about it? How do I get real-time results that allows me to react and respond and do something quickly?
So one thing that differentiates what we're doing versus our competition is that we have a fairly advanced way of doing predictive analytics in terms of the data that's coming in. We're also evolving into being more of a control platform, right? So as we detect these conditions in the network, we should be able to proactively go in and say, either divert services or shut down things, or in the case of SDN, spin up new instances, right? Which helps with NFB. It's the role of the performance management platforms in the future to not just be a passive observer, right? Because you have a lot of capacity, much more complexity, much more density of services, right? You're not going to wait for 3 days to get a report, right? Deliver it to someone and then do some corrective actions. You want 90% of the actions that can actually affect your network to be proactive.
So in fact, if we have fiber, and if fiber has an outage, we want to be able to turn up an AOptix circuit very quickly in response to that outage. And we want your system to not only monitor that, but predict it, so that in fact, I don't even see the outage. Is that how your system might work?
Absolutely, and ad hoc systems are actually a big area for us. We, because we have this something we call point, acquire, and track that allows us to get alignment between our two units in 20 minutes or less. You can run the units up on a cow or a colt, get them aligned within 20 minutes, and boom, you have 2 gigs of connectivity, and you could monitor it for us.
Absolutely.
Sounds like a marriage made in heaven.
Sounds good.
Okay.
Sounds great.
All right, now we get out of the way. Sorry, guys, you didn't have time to ask your questions. But we're going to get out of the way now. Thanks. Thanks,
No,
everybody.
it's